All right, Scott Peterson here. We're here down at our locally owned shoe store, FootZone. They do a great job. Today is packet pickup day for Heaven Can Wait, always supporting the local community. I send a lot of my patients down here for shoe fittings. They have an amazing team that takes care of my clients, as well as the average athlete and also just people that like good running shoes. So we're down here to talk about some of the different types of shoes and orthotic interface. So let's head on over to the shoes and we'll take a look. All right, so I've pulled a few shoes out that seem to be the most popular selling shoes right now, and I would like to talk about the orthotic interface and the different types of orthotics and how they fit in there. So first and foremost, let's talk orthotics. There's hundreds of different styles and combinations, everything from 3/4 length, super stiff hard plastic, to soft gels. This is a viscoelastic polymer. It's a two-part mixed resin that we fabricate. It is always going to be a little bit thicker than a low-profile athletic orthotic. Now this is a functional orthotic, so this is a 3/32 co-poly plastic, 5mm Yuko top, and then a firm posting bottom. It stores energy and returns it to the body. This is my runner's most favorite orthotic. Now, when we start to talk about other plastics and other plastics that we use is a co-poly. So that becomes, this is a co-poly plastic. I use the black because people, if they ever get a sandal, they don't like to see the white shining through. So this has some flexibility to it, unlike the polypropylene. So polypropylene is super stiff. Now this is 3/16 polypropylene. Depending on what your pathology is or what the doctor writes the order for, depends on what we use. So this is going to be something that we really have to control the skeletal alignment, balancing the subtalar neutral. We want to make sure that we hold that longitudinal arch in its best, strongest position. Now this does not have a lot of give, so it's very positive, very blocky. My athletes don't really like that. They like a little bit more dynamic, a little easier ride, more of a semi-rigid. And that semi-rigid takes us back to this product, 3/32, super thin co-poly. Now this is a polyethylene, super soft. You can actually dig your fingernail into it and it'll warp. Not a great product, but when you combine the polypropylene, polyethylene, you end up with co-poly, and this is a great product. Been using it for decades. So, different shoes that I pulled out have different trim fits. So some people go, well, why can't I have one pair of orthotics to fit all the shoes? Every shoe is manufactured on a different last. Now the different last has to do with the shape of the shoe. So if we grab an ultra shoe, which has zero drop. A zero drop means the heel is the same height as the ball of the foot. That trim pattern, and it has a very, very boxy toe. So the toe box is really wide, which is great for bunions, great for hammer toes. There's a lot of good benefits to the shoe. If you're coming off of a Hoka shoe or your traditional Brooks Beast, Brooks Aerials, that trim pattern is different. And so when we're taking your custom fabricated orthotic that is anywhere from $300 to $500 and we're trimming it, we want to trim it to fit your shoe. So you can see the different shapes. This would being the Ultra, this being your standard Brooks. This is off the Glycerin, and this is my favorite shoe. It has a medial stability, but yet offers a lot of cushioning. And you can tell, still wearing them. It's a great shoe. It's just a different trim pattern. So that's what I wanted to point out as far as with orthotics go. Now, when we're talking more of an accommodative orthotic, accommodative is a softer gel. So this is the viscoelastic polymer. Now when we start talking trimming the orthotic to fit in the shoe interface, the amount of arch that we have to cut out, the amount of width of the heel and instep will be dictated by the shoe. So this width has to be considered. This shape of the heel has to be considered. The arch length and how much it rises. This is a really good shoe for fitting a silicone orthotic into. Then when you grab a different shoe, let's see if I can find, this is the Bondi. The Hoka Bondi. Yes, so this is the Hoka Bondi. You'll see that right in this area in the heel cup, it's concave. Well, that concave I have to grind into the orthotic. See how narrow it gets here at the width or the throat of the shoe. I have to grind the orthotic narrow, which isn't a big deal at all until you want to put this soft orthotic into a different last. And we're just going to let me grab the Brooks Beast, because this is a great shoe for building orthotics for. So the Brooks Beast has a board last. It sits flat. It's wide and it's flat. So these edges don't have to be tapered as much. When you go to from a tapered shoe like the Bondi into a shoe like the Brooks Beast, what happens is when you step on it, the orthotic can flatten out. You don't have the proper stability for the shoe you're wearing. So I just want people to understand that each shoe is going to allow the orthotic to fit differently. If anybody ever has you step on an orthotic without a shoe and says, well, it doesn't support your foot, it never will. An orthotic's designed to be in the shoe. The shoe is part of the brace. We need the good stiff heel counter to help hold the heel in place. We need a good stability through the arch so the orthotic is supported. And that goes for all the shoes, or all the orthotics. Functionally, stiff plastic, a softer plastic. Oh yeah, another thing that this thin 1/8" polypropylene plastic orthotic's great for is racing spikes, cleats for soccer, lacrosse, softball. This is a great orthotic for that. If you get any kind of excessive pronation, any kind of shin splints, this is your go-to. So that's kind of my shoe spiel. Hopefully that'll help some people understand. Thanks.